So going back to all the reasons why flash is created, I'm going in the same order here then. So avoid high metal temperatures, and over on the right here is a phase diagram for an aluminum silicon alloy like 413 alloy or 380 or 390 alloy. And you can see that the red arrows here are pointing to the construction lines in this diagram, which show the melting or the liquidus temperature is what it's called. It's the temperature at which, upon heating, the metal it becomes fully liquid. And as you can see on the bottom here, as you change the silicon content of the alloy, the melting or the liquidus temperature changes tremendously. And so you have to know what the melting or the liquidus temperature of your alloy is, and then calculate the amount of superheat you want or desire to make the casting. And quite frankly, very often that's somewhere around 50 degrees C or something like that is a good starting point. So knowing the melting or liquidus temperature of your alloy is important, and in engineering, if you will, the temperature that you're going to cast the metal at is important. If you go too high, you're going to have flashing troubles, among others. So secondly, then, when you consider the tooling you're going to put in a machine, you have to consider everything together as a system. And so you want to make sure that the platens and the base of the tooling, you may have to use a base plate to spread out the load on the platen if the die is too small. You want to make sure everything's mechanically, the loads are mechanically distributed well, everything's mechanically rigid, and generally thermally stable to minimize thermally induced clearances from developing.
To purchase access to this course, visit the NADCA Marketplace at www.diecasting.org/store. Purchasing a course through the online education system grants you 1 year of access to the recording, presentation, support material, and test when applicable. NADCA video news and information is brought to you by the following sponsors.